Dear students, today I am giving the fourth video on topology, that is especially on the product topology. We started the theorem with x alpha to alpha, alpha in the index set be an indexed family of topological spaces, and let b alpha be a basis for x alpha to alpha for all alpha in the same index set. Then b, which is the correction, pi b alpha, or b alpha is in b alpha, and b alpha equal to x alpha except for finitely many values of alpha in index set. Then this b is a basis for the product topology on pi x alpha. This is what the theorem. Here to prove that b is the basis for it. B is the basis for the product topology on pi x alpha. Proof is given. W be an open set with respect to the product topology. You are taking W as an open set with respect to the product topology on pi x alpha, that is the product space, and let x alpha in index set is an element of this particular W. Then there exists pi u alpha, where u alpha is open in tau alpha, and u alpha equal to x alpha except for finitely many values of alpha in the same index set, and such that x alpha in the index set is an element of pi u alpha, which is subset or equal to W. Suppose u alpha not equal to x alpha for alpha equal to beta 1, beta 2, etc. beta n, then x beta I is an element of u beta I, which is a subset not equal to x beta I for I equal to 1 to n. That is by the selection. And there exists b beta I is an element of the script b beta I, such that x beta I is an element of b beta I is subset or equal to u beta I, which is subset or equal to subset not equal to x beta I for I equal to 1 to n. This we are reaching at the base definition form. Consider pi b alpha, where b alpha equal to x alpha for alpha not equal to beta 1, beta 2, etc. beta n. Then x alpha is an element of pi b alpha, which is subset or equal to pi u alpha, which is subset or equal to W. That is what the definition of a basis. Hence the given correction B is a basis for the product topology on pi x alpha. That is the proof of the theorem. Coming to next theorem, let y alpha u alpha topology u alpha in the index set be an indexed family of topological spaces. Let u be the product topology on y, on the product space y equal to pi y alpha in the index set. Let x2 be a topological space. Let f from x to y be a function, and f is continuous if and only if pi alpha composite f is continuous for each alpha in the index set. So necessary and sufficient part both you have to prove. First part you are taking. Coming to the proof, first part. First suppose that f is continuous, okay, and we know pi alpha is the projection function, pi alpha is continuous, so it follows that pi alpha composite f is continuous. Composition of continuous functions, again continuous. Conversely, the converse part, suppose that pi alpha composite f is continuous for alpha in the index set. Consider a sub-basis element pi alpha inverse u alpha, where u alpha is an element of topology u alpha. And what about f inverse of this element? F inverse of pi alpha inverse u alpha, that is f inverse of pi alpha inverse of u alpha, that is we are writing in terms of composition, or f inverse composite pi alpha inverse, that is nothing but pi alpha composite f inverse. So we can write it as this is equal to pi alpha composite f inverse u alpha, but pi alpha composite f is continuous. Therefore pi alpha composite f inverse u alpha is again open in X. That is what is shown in the figure. X to y. F is function from x to y. What is y? Y is pi by alpha. So the product space y to y alpha, that is what the projection pi alpha. We have taken the composition, the pi alpha composite f, that is from x to y alpha. So clearly this composition or f is continuous. So remarks are given. Remark 1. Statement. Let x alpha, tau alpha, alpha in tau be an indexed family of topological spaces. In the product topology on pi x alpha is the weakest topology on pi x alpha, for which each projection map pi beta from product space pi x alpha to x beta is continuous. That is what the remark. You can come to the proof of it. Let tau be the product topology on pi x alpha and u be any topology on pi x alpha for which each projection map is continuous. Selection visit. What do we have to prove? We have to prove that this tau is subset or equal to u. Let B be a basis element for the product topology on pi x alpha. Then how to write this basis B or basis element B is capital B equal to collection of pi u alpha, where u alpha equal to x alpha for alpha not equal to beta and beta etc. beta n, and u beta I is an element of tau beta I for I equal to 1 to n. Then pi beta I inverse u beta I is an element of u, that is it is open. For pi beta I is continuous with respect to u, that we know that pi beta I is continuous with respect to u. Therefore pi beta I inverse of u beta I is again open. So whatever this intersection part, the intersection of I equal to 1 to n, pi beta I inverse u beta I, it's again in u. The finite intersection is again in u topology. Or B is an element of u, or tau is a subset or equal to u. That's what a remark 1. Now we are coming to remark 2. Let x alpha tau alpha in the index set be an indexed family of topological spaces. Consider the box topology on pi x alpha. Then each projection map is an open map. Proof. Let beta in index set. To prove that pi beta from pi x alpha to x beta is open. For that we are taking an open set. Let W be an open set in pi x alpha. So we have to prove that pi beta of W is open in x beta. For that we are taking an element, let y beta element of pi beta of W. Then there exists small x in W such that y beta equal to pi beta of x, that is under pi beta the image of this. It's what taken as y beta. Pi beta of x equal to y beta. Now x in W and W is open with respect to the box topology on pi x alpha. Then there exists a basis element pi u alpha in the index set in such a way that u alpha is open, u alpha and tau alpha, such that x is an element of pi u alpha which is subset or equal to W. What does it mean? That is pi beta of x is an element of pi beta of pi u alpha which is subset or equal to pi beta of W. That is pi beta of x is y beta which is an element of u beta which is subset or equal to pi beta W, where u beta is in tau beta. Therefore pi beta W is open in x beta. It shows that pi beta is open. Now coming to remark 3, since the box topology is finer than the product topology, the projection map is an open map if we consider the product topology on pi x alpha. And that's all about this video. and the detailed notes are also given. You can just check the notes here properly video, watch it properly the video, and any doubts are there means you mark it, we can discuss in the next class.